Hi everyone, here's another project I've been working on. So I made a video a few months ago about this amp, or the another brand of this. They're exactly the same. I think they just resell the same amp. So it's a tube preamp with a solid state output, and it sounds great. It's got Bluetooth on it, and yeah, it's quite an amazing amp that can drive loud, large speakers. Very clean sound. The only problem I noticed was it makes disgusting clicking sounds, which I really never really noticed, because when you push this down, it's not actually turning it off. All it does is disconnect the output to the speakers, because it's still warm. So I never noticed the clicking sound. So I sent the original one back, which I purchased on Amazon, and I thought maybe there was something wrong with it. So I purchased this from AliExpress, which is cheaper. I think this was 45 quid. And it does the exact same thing. So I really like this, want to keep it. So in the end, I searched up some circuits and made this. So I'm still making a case for it. So here's the PCB. I'll show the schematic later. You've got two relays, got your output, you've got 3 transistors. Q3 is the one that drives the relays. Q1 and 2 are the delay circuit, so this adds a delay, and you got power input, on off switch, and 2 LEDs, one for the power indicator and the other one is to indicate if the protection is on or off. And you've got an option to turn off the LEDs if you don't like it. And you've got some flyback diodes here for the relays. So common ground on both sides. And then got an output panel here. This one here that I assembled. I still need to install this. So the way it works is you feed the power. So the amplifier comes with its own 24 volt supply. So you feed it into this first, into the speaker protector, and then I wire it and then feed it back out into the amp, because I want the same power, not a separate power, to run both devices at once. And I also have these gold-plated banana jacks to connect the speakers. So here's the thing: the output, the ground output on this amp is actually not common ground. So typically on an amp, the negative is actually connected to the ground, the DC input. It isn't. So when I originally designed the circuit, which is this one here, the ground here was connected, or the output of the speaker, I assumed it was ground, and I connected to the ground with the power input, and it obviously it does not like that. So this was a waste of time. So I redesigned it. This circuit actually detects DC. So this version here is missing the DC detector, but I'm more concerned about the startup noise. So I'm going to put this together and demonstrate the horrible sound it makes when it's turned on for the first time. So I've just got one speaker here. It's a T-Bow Harmony 2. Just going to connect up the amp and I'll show you the noise that it makes. So here's the speaker connected to the amp. The amp already has power turned on, so it's still live inside. So some of the components are getting power because it gets warm over time. So the speakers are disconnected. If I flick the switch, no click, and I can start playing, and it's absolutely fine. So watch what happens if I leave this switch on and turn off the power, because I don't like leaving these cheap switching power supplies on. So I'm just going to turn on the power. Look at that speaker. That does not look good. So I'm now going to connect it to my speaker protector. You definitely don't want to plug in some expensive speakers. These are only £40 to this amp. It will destroy them over time. So here we go, it's all connected. So the power for the amp goes into this, and at the same time it's also fed into the amp. So both are powered at the same time. So when this turns on, there is a delay before the speakers are connected. So rather than use a bunch more cables to test, I've just connected some of them directly. So this cable here, the white one here, is the input. The yellow is the output to the speaker, so that goes to the speaker. And then it's a common ground for the speaker. They aren't connected to the common ground of the power supply, but common ground of the speaker. So only one speaker is connected, but just to prove to you, so it's in the on position, power's off, got some music playing, so nothing output at the moment. So I'm going to turn on the amp and there should be no clicking sound like before, or the thumping sound of the speaker almost pops out. So here we go, it's on, 3-second delay, there it's on, and then the music's playing. So that works, the delay. Because I couldn't incorporate the DC detection because of the common ground issue, you do get the transient when you turn it off. So if I turn off the power, you get that, but it's not so bad. You saw earlier when I turned it on, it was flapping like 4 or 5 times, so much better. I'm going to make a case for this and I'll talk about the schematic. Here's a close-up of the speaker protector PCB. Got the 2 finder relays, so there could be other types of relays. I've gone for high current ones, just because over time the contacts can get damaged over from arcing. If there's DC leakage, that shouldn't be the case. They were cheap anyway, so you can use miniature relays. The yellow JST connector is the output indicator to indicate if the relays are on or off. When it's lit, it means the relays have been activated and not protecting. The small red JST connector is the power indicator LED. This little micro switch here controls whether the LED is on or off. The black JST connector is the power switch, and the red JST connector is the power input. It runs on 24 volts DC. There's your speaker output terminals, input and output. They share each channel, so left channel and right channel, they share the same ground. It's not the same ground as the power ground, it is separate. I've made a case for it. It's made from 5mm perspex. The outer dimensions are 8.5 by 8.5 centimeter. The spaces are 35mm high, so a total height of 45mm. Got a power switch LED and the relay indicator LED. Just going to put it back together. Top cover's back on, so power input for the amp, and then it feeds back out again to the amp. Turn on the power switch. The relay's been activated. Here's a schematic for the speaker start delay. This capacitor here adds a 3-second delay for turning on the transistor switch to drive the relays. These 2 transistors are part of the delay circuit. I've put 2 resistors here because the current flowing through them can make them a bit warm, because this transistor has a low gain. And you got the flyback diodes here to release the or put a return path for the current being released from the relay coils. A couple of JST connectors here for the LED switches. And you've got the power switch here, the relay LED, power LED, and a little micro switch to turn off these two LEDs. I worked out the base resistor, which are R5, R6 and R4. So R5 and R6 are the base resistor RB. So the MPSA 92 has a gain of 25. To work it out, you work out the load current. So the load current for this is just under 50 milliamps. So 50 milliamps divided by 25, and just to make sure the transistor is saturated, multiply it by 1.3, gives you 0.0026 milliamps that needs to be applied to the base in order to saturate the transistor and turn it on properly. So to work out the RB, you take the voltage in and subtract the VBE. I believe in this case with this transistor it's 0.7 or it's 0.9. Doesn't make too much difference. You then divide it by the load current, which gives you about 9k. So putting two 18k resistors in parallel gives you 9k. So it's a really simple circuit. There's no DC detection or anything like that. Let's have a look at the PCB. So double-sided PCB, lots of thick traces, especially for the speaker output terminals. I've made it as small as possible. If I'm making it too small, the relays do get quite warm. So let's have a look at the 3D view. You can see the 4 JST connectors, relays on either side, speaker connectors on the rear. I used a solid polymer capacitor here just because I had them lying around, and it does get warm. Not that warm. The normal capacitor or standard electrolytic capacitor is 85 degrees, that would have been fine. But I went for 105 degree polymer just because I had it and it works. Does not cause any stability issues because of the lower ESR. Some of the components I found quite hard to solder because the pads aren't correct. This drawing is actually, this 3D model is wrong. There is actually about half a mil space on the pads. It's very small to solder, but it is doable. Everything else, most of the pads are actually modified. These are really hard to solder, these Zener diodes, because they're round and roll off. You have to hold it with a tweezer and solder them. Other than that, it's quite easy to put together. There's ground fill on top and bottom layers. So thanks for watching.